Surprisingly, Einstein did not receive the Nobel Prize for the theory of relativity. Instead, he received it for the photoelectric effect. So let's investigate it. To start off, the photoelectric effect describes ionization of a material when light is shined on it. To further elaborate, ionization of a material is when electrons are ripped right out of the atom, so it becomes an ion. Another thing to remember is that light is not continuous. It travels in discrete energy quantities, or packets of energy, or chunks of energy, otherwise known as quanta. This was formulated by Max Planck in 1900. So if you imagine a metal with electrons displayed as shown, and you must notice that visible light does not ionize the metal. A higher energy photon is required for ionization. So if ultraviolet light is shined on the metal, electrons will be emitted from the metal due to excitations. An electron emitted due to this matter is known as a photoelectron. So it's important to note that intensity does not affect the emission of electrons. Intensity, by the way, is the power transfer per unit area. But for our terms, we will just say it's the amount of photons. What affects ionization is frequency. Frequency is defined as the number of waves that pass a point. You could also consider the number of pulses. Notice how I have a low wavelength wave, but a higher frequency. This is because the waves are much more compact to each other. On the other hand, a more spread out wave has a lower frequency because of a larger wavelength. This is because if you look at the frequency equation, you'll notice that the larger the wavelength, the smaller the frequency. We can say that frequency is directly proportional to the wave's energy. Every metal has its own work function. That is, the minimum amount of energy required to rip electrons off a solid. I should make clear that I use the term ionization, but it's important to know that ionization energy refers to the removal of electrons from a gaseous state of matter, whereas work function is for solids or metals specifically. But if we want to find the energy of a photon or emitted electron, how do we find this? So the correct formula is E equals hv, where energy is in joules, H is Planck's constant, which is approximately equal to 6.626 times 10 to the negative 34 joule seconds, and V is frequency. It is the cycles per second, which is equivalent to 1 Hz. So that, my friends, is photoelectric effect. It's what Einstein won the Nobel Prize for. Thanks for watching.